Hello future professionals, welcome to day 32 of our top 100 coding question analysis. Today, we are challenged with a question to right rotate a given list by k number of times. Now that our problem statement is defined, let's have a hands-on experience. Let us assume that we are given with a list containing the numbers 1, 2, 3, 4 and 5. And we are asked to rotate this list by 2 times. That is, our k is equal to 2. Now, what does rotate mean? Rotate means that to right rotate means to push the last element to the first and all the other elements to the right. Okay. So, what happens after the first rotate operation? After the first rotate operation, the list would look like 5, 1, 2, 3, 4. Here, we see the last element has come to the 0th index and all other elements have moved to the corresponding right indexes. Right. Now, we are asked to rotate it by 2 times. So, we have rotated it once. Let's rotate it 2 times. After second rotate operation, 4 would come here and all other elements will move to right. Okay. So, at the end, that is after 2 rotations, our list would be like 4, 5, 1, 2, 3. Right. This is our output. Okay. Let's now look at the methodology to obtain or to rotate a list. We look at the most preferred way. There are multiple ways. The most preferred way is big O of n time complexity and big O of 1 space complexity, because we rotate within the original array itself, so there is no auxiliary space that is created. This is preferred just because of these two reasons, right? It requires less time to rotate and it also takes no other space, right? So the most preferred way is to reverse the list, right? So let's take the original list, that is this, right? We'll take the original list. This is our original list. Right? We shall reverse the entire list. That would become 5, 4, 3, 2, 1. Right? This is the reversed form of the original list. And how many times are we asked to rotate the list? K's value is 2. Right? So, first step is to reverse the entire list. The second step is to reverse first k elements. That is, we must reverse, this is our output after the first reverse operation. So the second step is to reverse the first k elements, that is first 2 elements, right? Their indexes would be 0 and 1. The other indexes starts from 2, 3, 4, right? So after the second step, our output would be 4, 5, 3, 2, 1, right? Now let me put the indices. Now the last step, that is the third step, is to rotate all the remaining elements. That is, we have rotated these two elements, so we shall reverse all the remaining elements, that is starting from 3 to 1. So the output after the third step would be 4, 5, 1, 2, 3, right? This is our output after the third step. Is this not equal to the output we got earlier? That is this one. 4, 5, 1, 2, 3 is the output. Here also we have got 4, 5, 1, 2, 3 as the output, right? So this is the methodology that we'll use to rotate the list. Let's revise it once again. First step is to reverse the entire list. The entire list is reversed, right? Starting from 1 to 5 is reversed. Next, step 2 is to reverse the first k elements. That is, now we have the k as 2, so we'll reverse only the first two elements separately. After reversing the first two elements, we get 4, 5, 3 to 1. We have not reversed the remaining elements in the second step. In the third step, we reverse the remaining elements and we get the final output as 4, 5, 1, 2, 3, which is equivalent to our output, right? 4, 5, 1, 2, 3. Now, as this is an important question in our coding rounds, let's look at the edge conditions as well. Edge conditions are nothing but certain critical points that needs to be taken care of, right? The first edge case is, what if array is empty? There is no point in reversing, so return or output empty list cannot be rotated, right? The second edge condition would be, if the number of rotation is greater than the number of elements in the list, right? What if, let's have the example right again, 4, 5, right? If this is our list and k is 7, right? Let's assume first, when the number of rotation is equal to number of elements in list, right? How many elements do I have? 1, 2, 3, 4, 5, right? If k is 5, what can we conclude? So we have to rotate this list by 5 times. When I rotate it first time, 5 comes here, right? In the second rotation, 5 comes here. In the third rotation, 5 comes here. In the fourth rotation, 5 comes here. In the fifth rotation, 5 comes to its original position, right? So will all the elements. So the output after 5 rotations would be the same original list, that is 1, 2, 3, 4 and 5, right? Now what happens in the sixth rotation? In the sixth rotation, again 5 goes here, The output will be 5, 1, 2, 3 and 4, right? What will happen in the 7th rotation? If k is 7, again this list will be rotated. That is 4, 5, 1, 2 and 3, right? This will be our output. So what can we conclude from here? When k is equal to the number of elements in the list, we do not have to rotate the list, because after rotation the output will be equivalent to the original list, right? If it is 1 greater than the number of elements, then we rotate the list by once. That is, effectively the output is equivalent to, if we have rotated the list by 1. If we rotate the list by 2 more than the number of elements, that is 7, as we have 5 elements, it is equivalent to rotating the list by 2 times, right? So what can we conclude from here? If k is 5, we shall take a modulus of length of the array, right? That gives us the remainder as 0. So we shall rotate only these many times, right? When it is 6, we shall take the modulus, that is the remainder, and rotate it by only these many times. When we are asked to rotate it by 6 times, we will take the remainder, that is number of times to be rotated, modulus the length of the array. It will give us the resultant, that is how many times actually the list has to be rotated, right? Next, if it is 7, we will take a modulus length of the array, that gives us the result as 2, which gives us effectively how many times should we rotate the list. Now that our edge condition with respect to rotate is over, let's look at how reverse happens. Right? We'll have the same list, that is 1, 2, 3, 4 and 5. Right? The indexes are 1, 0, 1, 2, 3, 4. When we have to reverse this list, we have to take 2 pointers, that is start and end, right? So we will swap the element in the start index with the element in the end index, right? After we swap, the output will be 5, 2, 3, 4, 1, right? Now the first and the last element is reversed, so we will move the start pointer to the next index to the right and the end index to the left, right? N comes here. So we will now swap the element present in the S index, that is start index, and the element present in the end index. What will be the output? The output will be 4, 3, 2 and 1, right? Now what has happened? We have got the output, right? But in our program, our start will come here and end will come here, because end is decremented by 1 and start is incremented by 1, right? So when start's position is equal to equals position, we shall terminate the reversal process, because we would have obtained the reversed list, right? So next what happens? We have to rotate these two, right? So what will be the start index? Start index will be 0 and n index will be number of elements, right? Number of rotations is 2. How many elements are there? How many elements should I rotate? I have to rotate 2 elements. What would be the last index? That is this index. What is this index? 1. How can I derive it from k? That is k minus 1. K is 2, minus 1 will give me the index 1. So effectively I will rotate 0th index and the first index, that is effectively 2 elements. Now if I rotate this, that is effectively reverse, it would be 5, 4, 3, 2, 1. Start is here, end is here. I will swap. The output will be 4, 5, 3, 2, 1. Right? And next what happens, as start is incremented by 1 and end is decremented by 1, end comes here and start goes here, right? So when start is only less than end, we perform reversal operation. Else if start is greater than end, we terminate, right? The third step would be to reverse these elements. What is the index? 0, 1, 2, 3, 4. Okay. Now what will be my start index? Start index will be 2. That is nothing but k. Right? And the end index would be the length of the array minus 1. The length of the array is 1, 2, 3, 4, 5. 5 minus 1 is 4. Which is my last index? It is 4. So when we reverse this, that is 5, 4, 3, no sorry. When we reverse this, the previous step output will be our input, that is 4, 5, 3, 2, 1. The start index will be here, end index will be here. So let's reverse. We'll get the output as 4, 5, 1, 2 and 3. Now start will be incremented to this position, end will be decremented to this position, start will be here, end will be here. So they point to the same index, so we terminate. Now we have got our final output, right? Now that we have discussed all the edge cases as well as had a hands-on experience of solving the problem, let's derive the logic out of these experiences. The logic is that first we get the array and the number of rotations. K from user, right? The second step would be to reverse the entire, right? Third step would be to reverse the first k elements, that is from 0th index to k minus 1 index, right? The fourth step would be to reverse the remaining elements, that is from kth index to the length of the array minus 1, right? Now we would have obtained our final result, that is our final output. So we print the output, right? Next, as we have completed our program, let's terminate it. right? Now that we have looked at the logic, let's put it into practice by coding our program. Now let's study our program. The program is to right rotate the list by k number of times, right? First, we have defined a function get user input. Within here, we get the number of elements in the list, to know the length of the array, and append the number of elements to the list, right? So effectively, we are getting the list from the user. Next, we get the number of times the list is to be rotated, right? Then we return both the numbers array, that is numbers list, and the number of times it has to be rotated, that is numbers and k. Next, we have defined a function to reverse the list, right? This function is to reverse the list. Okay, it gets three parameters, that is the list numbers, then start index and end index. Okay, now we declare that when start is less than end, right, we swap the start index element and the end index element with the end index element and the start index element, right? Swap the first and the last number, right? Now what do? We increment the start by 1, that is move to the next element in the right, and end index is decremented by 1, that is move to the next element in the left. While this condition is violated, comes out of this loop, then we return the numbers list, right? Next, we have defined a function to rotate the list. It gets two parameters, that is the numbers list and the number of time it has to be rotated. Here we use the percentage symbol, that is modulus, to find the effective number of times the list has to be rotated. This takes care of the edge condition when k is greater than the number of elements in the list, right? Next, we call the reverse list function and pass the numbers list with start index as 0 and the end index as the last elements index, right? That is length of the list minus 1 to reverse the entire list. First we reverse the entire list. Next, we call the reverse list, same function, and pass the numbers list with the start index as 0 and the end index as k minus 1, right? Effectively reversing the first k elements. Next, we call the reverse list and pass the numbers list, and now the start index is k and the end index is length of the list minus 1, that is effectively reversing the remaining elements in the list, right? Now that we have obtained our output from the third step, we shall print our output, right? Now that we have defined all our required functions, we will call our functions, right? When I call the get user input function, it returns me two values, that is the numbers list and k, which I store in numbers and k variable respectively, right? Next I call the rotate list and pass two arguments, that is the numbers and k, right? As we do not have any errors or warning signals, let's run the program. The program is asking me the number of elements in the list. Let me enter 5. The element 1 would be 1, 2, 3, 4, 5, right? How many times should I rotate the list? Let me rotate it by 2 times. I get the output 4, 5, 1, 2, 3. This is similar to our output, right? Let me try for the same list but rotate it by more than the number of elements present in the list. Let me enter 7. See, I have rotated it effectively by only twice, right? Thus, we have successfully completed our program. I hope you would have got the best out of this video. I recommend you subscribing our channel to get more such interesting videos. I also recommend you to like and share the video if you find it supportive and interesting.